In this video, we'll talk about friction. So in this picture, we have a mass that's being pulled by a force. The mass sits on a rough surface, so friction applies. There's the weight down and the normal force up. The applied force points to the right, and friction opposes that force. Friction is a reactionary force that can only oppose an applied force. If we look at solving this with Newton's second law, vertically we have the normal force minus the weight, and we know that it doesn't go up or down, so acceleration is zero. That means that the normal force equals the weight, and the weight is mg. In the horizontal, we have the applied force minus the frictional force results in your MA. So far we haven't done anything new. This is all procedures that you've done several times. Now, friction, as I said, was a reactionary force, and that means it only exists in reaction to some other applied force. Secondly, it depends on several things. One is the mass of the object or the weight, but in actuality it depends on the normal force. So for instance, not just the weight, I might be pushing down on this mass. The normal force would be bigger because of that. So the normal force certainly is the primary factor that goes into determining how big the frictional force is. It also depends on the roughness of the surfaces, and that is taken care of by a coefficient of friction called mu. And mu is a value between 0 and 1, and it is a dimensionless, unitless number, and friction is equal to mu times the normal force. Okay. Now, there's two types of friction. If the object is not moving, then we have static friction. If the object is moving, then we have kinetic friction. And two equations that you'll know will take this main equation and will apply it in both situations. So the static friction, the maximum available, is equal to the coefficient of static friction times the normal force. Now, why do we say Fs max? This is the static friction, the maximum available static friction. If we apply a force, say 10 newtons, and the object doesn't move, then down here we would have 10 newtons minus friction. The object didn't move, so that must mean that the static friction in that case equals 10 newtons. Okay. If I apply 20, then the static friction is 20, and so on. At some point, though, then it breaks away. So static friction is a value that is less than the maximum available value, and it's in reaction to the other forces applied to the object. If the applied forces are less than Fs max, then the object will not move. If the applied forces are more than the Fs max, then the object will move, and we then use kinetic friction, which equals mu k times the normal force. Okay. So by doing this, we need to keep track of a situation for whether it's sitting still or moving. Now, mu s is a number between 0 and 1. Mu k is also a number between 0 and 1, and it would be a smaller number in most all cases. So if we were to graph the applied force here and the friction here, if you push a little bit, you get a little bit of friction. If you put a little more, you get a little more friction, and this would be static friction. As you reach a certain threshold, though, you get to a point over here, which is the value of Fs max, maximum amount of static friction. And after that, then, the applied force, no matter what you apply, the friction can only be the kinetic friction. And this force is usually less than the maximum available friction. So, let's take some numbers. Let's say our mass here is 10 kilograms. And let's assume G is 10 instead of 9.8. That would mean that the weight is 100 newtons, and the normal force is 100 newtons. Now, let's also assume that our static coefficient of friction is 0.5 and our kinetic friction is 0.3. These numbers will change depending on the two surfaces. But we can use these numbers to calculate Fs max. So in this case, this is 0.5 times 100 newtons. So the maximum available static friction is 50 newtons. In this case, it's 0.3 times 100 newtons, or 30 newtons. So if we take a look at this, let's say my applied force is, 30 newtons. Well, that is less than Fs max, so there's no acceleration, and therefore friction must equal, its static friction must equal 30 newtons. Any force that I apply that's less than 50 newtons, the object would not move, and in this case the friction would be 50 newtons. What happens though if I apply 60 newtons? So we'll do a situation where I have 60 newtons of applied force. Well, that is greater than the available static friction, so then friction can oppose it with the kinetic friction, which is 30 newtons. And then we have our 10 kilograms times A. When we solve this, A equals 30 newtons over 10 kilograms, or 3 meters per second squared. Hopefully this was helpful.